I pretended that I was writing your quiz for tomorrow. And so instead of, this is our practice quiz problem, this might be your quiz problem. Okay? So, what does this look like? What's the answer to this? 4 over x to the 5th.
Oh, yeah.
Remember, negative exponents go to the bottom. The flip thing, remember? So, this is your quiz question, right? So, what's this going to be? 3 over x to the 6th. You shouldn't miss that. Anything with a negative exponent is going to go to the denominator. The 3 does not have a negative exponent, so it's staying there. Everybody okay with problem number 1? All right, number 2. Now look, there's another negative exponent, right? What's it going to do to these two numbers? Flip them. So this is going to become 4/3 to the 2nd. The exponent stays 2, but once you flip it, it becomes positive. And that means square it all. So the answer is 16/9. How many got that? Good work. If you didn't get that, let's walk through this one. This is exactly the same kind of problem. So first thing your immediate eyes notice is that negative exponent. So what does that mean? We're going to flip that. So it's going to be 3/2 to the 3rd. Now you cube everything. So 3 times 3 times 3 over 2 times 2 times 2. Got it? No issues with that, okay. All right, here we go. Uh-oh, fractional exponent. What do fractional exponents mean? That's right, Marco, it's going like this. Radical, these are radicals. This is a radical. When you see a fractional exponent, it is a radical. Well, what's under the radical? 4/9 to the 1st. This tells you it's a square root. Now, what's the square root of 4? 2. And the square root of 9? There's your answer, 2/3. Anybody get that one right? A couple of you? Good, very good. Let's try this one. Same thing. Only what? This is a radical, but this is a cube root because of that right there. So it's the cube root of 8/27. Well, what's the cube root of 8? 2. And the cube root of 27? 3. So the answer to this problem is also 2/3. All right, everybody got that one? When you see a fractional exponent, you know you're going to need a radical. Uh-oh. This is a fractional exponent, but it's also negative. Deal with the negative. What does the negative do? Flip it. So this is going to become 4 over 25 to the 3/2. Now, it's a fraction. That means you're going to have a radical. This tells you the kind of radical. So it's a square root. It's the square root of what? 4/25 to the 3rd. Well, wait a minute. Let's do this part first. What's the square root of 4/25? 2 over 5, right? Now what do we still need to do? Cube it, right? It's a cube. So the answer is 2 cubed, 8, over 5 cubed, 125. Now that's a tough one. Let's do this other one. Do this one right here. Step by step by step, you got this. Here's the problem right here. Everybody see it?
Yeah.
See that? Deal with it. Take that, take care of that. So you're going to have 36 over 25 to the 3 halves. Got it so far? What does the half tell me? Radical. So you know you're going to, this tells you you're going to have a square root problem. You're going to have a square root of 36/25ths to the 3rd. Well, what's the square root? This part's easy. What's the square root of 36/25ths? 6 over 5. And then you have to cube that. So 6 times 6 times 6, 216. And 5 times 5 times 5, 125. And there's the answer. So I just did 2 examples of those. There's one more exponent problem to do. I remember before. So here we go. Here's the last one. What did you do as you were sitting there focusing on these problems? What did you do with this guy? What? Okay, so one option we have is to just look inside here and clean that up. Now, I'm not saying that's how you have to start, but that's an option. So inside the parentheses, I'm going to forget the part outside, making inside the parentheses, the 3 and the 2 don't simplify. There's only one x, so it's not going anywhere, it's staying there. But here I have some work to do. What happens to those 3 y's on the top? They come down. Mikey, you were going to tell me that? Okay, so they come down. Well, there's already 7 of them down there. So when I bring down these 3, I'm going to have 10 on the bottom. Now, nothing is moving with the z's. You have 5 z's over 3 z's. Think about that. What's going to happen if you have 5 z's over 3 z's? They're going to cancel. And you're going to be left with 2 extra z's on the top. Now the inside is done. There's nothing else to do on the inside. So at this point now we have to do the outside. Okay, so here we go. Obviously 3 squared is 9 and 2 squared is 4. Now what did we say the other day we're going to do with these exponents when we have a double exponent? X to the 5th squared. What do we do with those? Multiply. So this becomes x to the 10th, z to the 4th, and y to the 20th. And there is your answer. We'll do one more of those for practice, but that's your answer. Anybody have a question about that one while I write another one here? Anybody have a question about this? All right, so here's another example. When I sit down to write the quiz, it's going to be right in front of me. Just exactly the way I wrote that one. I'm just going to write another problem that looks like that. So you need to know how to do it. All right, so let's look at the inside. What's happening there? 4 and 12 will reduce, so we can make that 1 over 3, right? And the 3 x's are going to have to come to the top to join the 8. So we're going to have x to the 11th. Anything going on with the y's? Yes. They're going to cancel. Y's on y's are going to cancel every time. Who has more? The top. How many more? 2. So you're going to have 2 y's on the top. And what about him? Does he stay there? He actually has to come down, doesn't he? Because he is negative. Now, this is a situation where, see that 1, when we reduce that, you can either keep that 1 or lose that 1. It doesn't make any difference. What I want to remind you is if you leave it, 1 squared is 1, not 2. That's going to stay 1. All right, so what do we got? We're going to multiply those exponents. Here we go. X to the 22nd, y to the 4th. Watch it. 9, z to the 6. So there's your answer. Everybody okay with that? Okay. If you feel like you need, I did 2 of everything, but if you feel like you still need more practice, remember your exponent sheet, you still have that. It has the answers on the back, so you can work through some extra practice if you want to do that. All right, let's move on. Consider this sequence. All right, is it geometric? Why? Because to get from term to term, we are timesing by 2. And if that's what you're doing, if you just keep multiplying by something, doesn't have to be 2, it's geometric. So the answer to A is yes. What is the common ratio? 2. The common ratio is simply the number that you multiply by. What is the 17th term? So in other words, what is A sub 17? Izzy?
The first term, so 3 times the common ratio 2, and then n minus 1, so 16.
Beautiful. She is exactly right. Does everybody remember that from yesterday or whatever day that was? That we take the first term, and we multiply it by the ratio to the 1 less power. I do expect answers tomorrow, so if you come with no calculator, you have a lot of work right here. 2 to the 16th is a big number. I got, 196,608. Anybody have a question about that? All right, number 7 says, here's a sequence of numbers. Find the missing terms. So let's look at what we've got. And then we just got to figure out what's going on. So look at the numbers that you have here. What's going on? Minus 3. So our pattern is minus 3. Is it geometric? No. It doesn't matter. We can still fill in. And once we know the pattern, so how will I fill in this one? What will I need to do? Minus 3. So that's going to be negative 5. Minus 3. Negative 8. Tricky. Got to go the other way too. You got to fill in these. So instead of minus 3, we will add 3. So this is going to be 10 and 13. Is everybody okay with that? All right. All right, here we go. Now we have a few word problems. Maddie earns $8.50 an hour. Each week, she gets a 6% raise. How much will she make in the 12th week? Are we going to do something similar to this right here, you guys? Yes, we are. This time, we want the 12th term, because it's says how much will she make in the 12th week? With the 12th term. Okay, now what? Start with 850 and multiply by what? 1.06. Perfect. Why is it 1.06? Because we're increasing 6%, and in these problems, we never ever multiply by just the percent. It's always 1 plus the percent or 1 minus the percent. Okay? Then everybody understand why that's an 11?
Yes.
So now I'm going to my calculator, type it in. If you have a calculator, please type it in with us just to make sure you're doing it right. I got $16.14. Everybody good? Okay. Gray's car depreciates. What does that mean? Depreciates? Decreases. So Gray's car is going down in value 2.5% every year. If it is worth $27,300 now, how much will it be worth in 10 years? So would you agree I'm looking for A sub 10?
A sub 9. Oh, wait.
And what am I going to start with? 27,300. And what am I going to multiply it by? What? I heard it. 0.975. Okay, one more time. Guys, we've got to stop asking why. We never multiply by the percent. We're either going to multiply, so the percent is 0.025. We never multiply by that. We either multiply by 1 plus that number or 1 minus that number, depending on if we are increasing or decreasing. So you got a calculator. 1 minus 0.025 is 0.975. Why did I do the minus 1? Because this is a depreciate problem. If Gray's car were growing in value, I would add. What power is this going to? The 9. So 27.975 to the 9. I got $21,737.23. Okay, and then one more. Hannah saved $12.50 this week. She saves 16.5% more each week. How much will she save in the 9th week? So I'm looking for the 9th term, A sub 9. So what am I going to start with? 12.50. And then she is increasing, she's saving more. So 1.165?
Yes. To the 8th.
To the 8th power. Yep, that's exactly right. Looks like she's going to save $42.41 that week. Now notice that on this quiz, we had no need for logarithms, right? That'll be our next one. This is what's on tomorrow's quiz. This is exactly what's on tomorrow's quiz, okay? My guess is there'll only be 2-word problems instead of 3. But that's what it's going to look like. All right, are we good?
She would never know.
Maybe it might be. Yeah, I don't know. Actually, this is probably a good time to just go to lunch. Time out. Wait a minute. Stop.
It's 26.
No. I need you back at 56. I need you back at 56.
25 minutes.
Let's go. Have a good lunch.
Have you seen her lunch? It's balanced.
You get a balanced lunch.
It's very balanced.
I gotta get him more.